Somewhere over the central United States right now, the atmosphere is quietly loading a weapon. You cannot see it, you cannot hear it. But every model, every satellite pass, every balloon launch sent up into the sky this week is drawing the same picture, and it is not a comfortable one. A dome of high pressure has parked itself over the south and southeast, baking the ground until it cracks, while cooler, unstable air keeps circling just to the north, refusing to leave. Between those two masses sits a boundary. And boundaries like this one, when the moisture finally arrives and the jet stream finally digs in, are exactly where the worst weather in America is born. Forecasters have a phrase for what is developing. They call it a dangerous setup. It is not dramatic language chosen for headlines. It is the actual, technical, agreed-upon term meteorologists reach for when the ingredients on the table are all present at once, when there is nothing missing from the recipe, and when the only real question left is not if severe weather erupts, but where and how violently. Let's start with what the atmosphere is actually doing, because the pattern building across North America this month is unusually split. In the west, heat is dominant. In the south and southeast, from Texas through Louisiana, Mississippi, Alabama, Georgia, Florida, and into the Carolinas, forecasters are already warning of heat indices climbing above 105 degrees Fahrenheit, day after day, with almost no relief overnight. That kind of heat does not just make people miserable. It bakes soil until it can no longer absorb rain, it dries vegetation into kindling, and it builds an enormous reservoir of energy at the surface, energy that has to go somewhere eventually. At the same time, a very different story is unfolding across the northern plains. There, the air has stayed unusually cool for this point in the season, and a broad area of mid-level low pressure sitting over eastern Canada is dragging cooler, more turbulent air southward. When you have a mass of scorching, moisture-rich air sitting still in the south and a mass of cold, dry, energetic air pushing down from the north, you have created what atmospheric scientists call a battleground. It is not a metaphor. It is the literal zone where warm and cold air masses grind against each other, where wind shear increases, where instability spikes, and where thunderstorms stop being ordinary rainmakers and start becoming engines capable of producing tornadoes, hurricane-force straight-line winds, and hail large enough to shatter windshields. This is the same broad mechanism that has already produced some of the most destructive weather events of the year. Earlier this summer, a multi-day severe weather outbreak tore through the central United States, putting more than 200 million people under some form of severe weather risk across a single stretch of days. Tornadoes touched down across Illinois. A tornado emergency, the rarest and most urgent warning the National Weather Service issues, was declared for towns like LaRose, Toluca, and Winona. After radar detected a large debris ball, a chilling signature that tells meteorologists a tornado is not just on the ground, but is actively lofting pieces of buildings, trees, and vehicles into the air. Baseball games were postponed. Over 130,000 customers lost power in a single evening in Illinois alone, with Cook County reporting more than 90,000 outages on its own. And in the days that followed, an outbreak evolved into something even more feared by meteorologists, a derecho. If you have never experienced one, a derecho is easy to misunderstand because it does not look like a tornado, and it does not sound like a hurricane, but it can produce damage that rivals both. It is a long, fast-moving line of violent thunderstorms that pushes winds outward in a straight line, sometimes for hundreds of miles, sustaining hurricane-force gusts far longer than any single storm cell could manage on its own. One derecho this summer produced 90-mile-per-hour winds as it tore across the Midwest, killing several people and leaving roughly 700,000 homes and businesses without power, the majority of those outages concentrated in Pennsylvania. Because of how the winds behave, pushing outward across a wide, straight corridor instead of spinning inward toward a central point, meteorologists say the safety response to an approaching derecho should be the same as the response to an approaching tornado. Get inside. Get low. Get away from windows. There is no time to admire it from a porch. So why does this matter for what is building right now? Because the same underlying ingredients that produced those outbreaks earlier this year, extreme heat baking one region, while cooler, unstable air pushes down from the north, are reassembling. The Storm Prediction Center in Norman, Oklahoma, the government agency tasked with forecasting exactly this kind of danger days in advance, has been issuing extended outlooks watching a corridor stretching from the southern and central plains up through the Midwest and into the Ohio Valley. Their long-range convective outlooks do not casually escalate. When forecasters start highlighting a multi-day window rather than a single afternoon, it usually means the pattern is not a fluke. It is a signal that the atmosphere is going to keep reloading the same weapon for days in a row. Layer onto this the monsoon. Across the Southwest, forecasters expect this year's monsoon season to be more active than typical, which sounds, on the surface, like good news for a region that has spent years fighting drought. And in some ways it is. But an active monsoon is also a double-edged blessing because the same bursts of tropical moisture that finally soak parched reservoirs can just as easily overwhelm dry, hardened desert soil in a matter of minutes, triggering flash floods that move with terrifying speed through canyons, washes, and low-lying roads that were bone dry an hour earlier. Flash flooding kills more people in the United States most years than tornadoes do, precisely because people underestimate how fast a few inches of moving water can become a fatal event. A vehicle can be swept off a roadway in less than 2 feet of fast-moving water. Most drivers do not believe that until they have seen it happen. And then there is fire. Forecasters are already flagging elevated fire potential, stretching from the Pacific Northwest down through parts of the South and East, a consequence of exactly the same heat dome that is currently baking the southeastern states. Antecedent dryness, the term meteorologists use for ground that has already been starved of moisture for weeks before a new dry spell even begins, is setting up conditions for what the Climate Prediction Center is calling a risk of rapid onset drought across portions of the southern and central plains and the lower Mississippi Valley. Rapid onset drought is exactly what it sounds like. It does not creep in over a season. It can develop in a matter of weeks, turning green landscapes brown and igniting the kind of explosive wildfire behavior that firefighting crews dread most, fires that move faster than evacuation orders can keep pace with. So picture the full board. In the west and northwest, fire risk climbing. In the south central and southeastern states, a heat dome intensifying for days on end with little overnight relief, priming both people and landscapes for danger. In the southwest, a monsoon capable of delivering both desperately needed rain and sudden deadly flash flooding. And sitting right in the collision zone between the scorching south and the cooler, more energetic north, an atmosphere primed for exactly the kind of severe thunderstorm outbreaks, tornado warnings, and possible derecho events that have already proven, this year alone, how much damage they are capable of inflicting. This is not speculation dressed up as drama. This is the actual architecture forecasters are describing when they use the word dangerous. Meteorologists do not reach for that word lightly because their entire profession depends on being trusted the next time they say it. When the Storm Prediction Center extends a heightened outlook across a multi-day window, when the Climate Prediction Center starts using terms like rapid onset drought, when regional forecasters begin warning that fire potential and flash flood potential are elevated in the very same week in different corners of the same country, it means the pattern has stopped behaving like ordinary summer weather and started behaving like a system building towards something that demands attention. Let's slow down and actually walk through how a day like this unfolds on the ground. Because numbers on a forecast map do not capture what it feels like when the sky turns green. It usually starts quietly. A morning that feels unusually still, unusually humid, with a haze hanging low over the fields. Farmers who have lived through enough of these seasons will tell you they can feel it before the first cloud even builds. A kind of pressure in the air, the atmosphere holding its breath. By midday, the heat has built enough instability that towering cumulus clouds begin punching upward. First as isolated columns, then merging into something darker, something with structure. Meteorologists watching radar start to see what is called a hook echo forming on the back edge of a storm, a shape on the screen that looks almost gentle, a soft curl, but which experienced forecasters know as one of the most reliable visual signatures of a developing tornado. Warnings begin cascading across phones. A severe thunderstorm watch first, calm and procedural, telling residents that conditions are favorable. Then, as cells intensify, a tornado watch, broader in scope, but still not an immediate call to shelter. And then, if the rotation tightens and a debris signature appears on radar, the warning nobody wants to receive. A tornado warning, sometimes escalated further into a tornado emergency. The rarest classification the National Weather Service issues, reserved for situations where forecasters believe there is a severe and immediate threat to human life. When that alert hits a phone, there is no ambiguity left in the language. Take shelter now. Do not wait to see it. Do not film it from a doorway. Get to the lowest level of the sturdiest structure available and put as many walls as possible between yourself and the outside world. Outside, if the storm follows the pattern seen in earlier outbreaks this year, the tornado itself may only be part of the danger. The same storm complex can be dropping hail the size of golf balls or larger just a few miles away, hail capable of denting vehicles, shattering skylights, and injuring anyone caught outside. Meanwhile, the broader system feeding these individual cells can be organizing into a squall line, a long chain of thunderstorms marching in formation. And if conditions align the way they did earlier this summer, that line can accelerate into a derecho, a single connected wall of wind capable of flattening trees and power infrastructure across an area the size of a small state in the space of an afternoon and evening. For emergency managers, the hardest part of a setup like this is not any single hazard. It is the fact that several hazards are stacked on top of each other across a wide geography at the same time. A community bracing for wildfire smoke in one region does not necessarily have resources to spare if flash flooding hits a neighboring county the same week. A power grid already strained by record heat demand for air conditioning becomes far more fragile the moment a derecho starts knocking down transmission lines. Hospitals treating a surge of heat-related illness can suddenly find themselves also treating storm injuries. Every hazard on its own is manageable. Stacked together in the same compressed window of days, they start to overwhelm even well-prepared systems. This is part of why meteorologists have grown increasingly vocal about not letting your guard down, even outside what people traditionally think of as tornado season. There is a persistent myth that severe weather danger belongs to spring, to April and May, the months most associated in public memory with sirens and storm chasers. But some of the most destructive tornado and derecho events on record have struck in the heart of summer in June, July, and August, when the atmosphere is loaded with even more raw heat energy than it typically carries in spring. The August 2020 derecho that tore across Iowa remains, to this day, one of the costliest thunderstorm events in American history, generating measured wind gusts over 125 miles per hour, comparable to a major hurricane, and causing more than $11 billion in damage in a single day, mostly to homes, crops, and the electrical grid. That event began the same way this pattern is beginning now: extreme heat over one region, cooler, unstable air intruding from another, and a boundary between them primed to explode. There's also the human psychology of these events to reckon with, because forecasters have noticed something troubling in how people respond to repeated warnings. When severe weather becomes frequent, when phones buzz with watches and warnings week after week during an active season, a kind of fatigue sets in. People start treating the alerts as background noise rather than a call to action. This is precisely the moment meteorologists worry about most, because the danger has not decreased just because the warnings have become familiar. If anything, an atmosphere capable of producing outbreak after outbreak in a single season is an atmosphere that has more energy circulating through it, not less, and the odds that eventually one of those warnings arrives just before, rather than well ahead of, a life-threatening event only grow the longer an active pattern persists. So what does preparation actually look like in the face of a setup like this? It starts with taking the distinction between a watch and a warning seriously. A watch means the ingredients are in place and storms are possible across a broad area. It is the moment to review your plan, check that you know where your safest shelter location is, and make sure your phone's emergency alerts are enabled rather than silenced. A warning means a hazard has been detected or is imminent in your specific location, and it is the moment to act immediately, not the moment to step outside to look. For anyone in a mobile home or a structure without a reliable basement or interior room, having identified a nearby sturdier shelter well before the storm arrives, not during it, is often the difference that matters most. For flash flooding, the guidance from meteorologists remains blunt and unchanged for good reason. Turn around, don't drown. It sounds almost too simple to be effective advice. Yet it remains one of the most repeated phrases in American emergency management because so many flood deaths happen the exact same way. A driver underestimating a stretch of water across a familiar road, confident their vehicle can push through, only to be swept sideways in seconds. Water only a foot deep moving with enough force can lift and carry a passenger car. 2 feet can carry away a full-size truck or SUV. In the dark, on a road you have driven 100 times before, that math does not feel real until it is too late to matter. For the fire risk building beneath this same pattern, preparation looks different, but the stakes are just as high. Communities in elevated fire zones are being urged to clear defensible space around structures now before red flag conditions arrive, not after smoke is already visible on the horizon. Evacuation routes that seem obvious on a map can become gridlocked or impassable within minutes once a fast-moving fire, fed by drought-stressed vegetation and gusty outflow winds from nearby thunderstorms, begins to run. The same storms capable of producing tornadoes and derechos elsewhere in this pattern can, in drier regions, produce almost no rain at all at the surface. Just dry lightning and outflow winds, a combination fire meteorologists consider one of the most dangerous ignition scenarios that exists. And what makes this particular setup worth paying close attention to is not any single ingredient in isolation. Heat domes happen most summers. Active monsoons happen most years. Severe weather corridors form and dissolve constantly across the central United States. What makes forecasters uneasy this time is the simultaneous alignment of all of it: heat stacking dangerously in the south and southeast, drought risk accelerating beneath that heat, an active monsoon threatening flash floods in the southwest, elevated fire potential stretching from the Pacific Northwest through the south and east, and a volatile boundary sitting between all of it, a boundary capable of igniting the kind of tornado outbreaks and derecho events that have already proven their destructive power earlier this year. There's also the matter of what comes after, because forecasters looking further out into the season are already discussing the potential influence of a stronger than normal El Niño pattern developing into the winter months. a shift that historically reshuffles storm tracks across North America and Europe alike. Patterns like these do not simply end when one dangerous week passes. They tend to hand off their energy to the next stretch of the season, meaning the conditions building right now may be less a single isolated event, and more the opening chapter of a longer, more turbulent stretch of weather extending well beyond the days immediately ahead. None of this is meant to induce panic. Panic causes people to freeze or to make poor decisions in the exact moments when calm, rehearsed action matters most. What this pattern demands, instead, is attention, genuine attention, the kind that means checking a real forecast source rather than scrolling past a headline, the kind that means having an actual plan for where you would shelter if a warning arrived at 3 a.m, the kind that means treating a flooded road as an obstacle rather than an inconvenience to drive around. The atmosphere does not care whether you believe the forecast. It is going to do what the physics tell it to do regardless. The only variable anyone watching this pattern can actually control is how prepared they are when it arrives. Meteorologists tracking the system are being unusually direct in their language, not because they want to generate fear, but because their entire discipline exists to buy people time to move to shelter, time to evacuate a floodplain, time to clear a fire line before flames arrive. Every hour of lead time a forecast provides is an hour that can be the difference between a frightening story people tell afterward and a tragedy that makes the news for weeks. The setup building across the country right now is giving exactly that kind of lead time. What happens with it, region by region, family by family, decision by decision, is still being written. To really understand why this particular combination worries meteorologists so much more than an ordinary hot week, it helps to break down the actual ingredients they are watching, because severe weather forecasting is not guesswork. It is closer to a chemistry experiment where 4 specific components have to combine in the right proportions for something explosive to happen. The first ingredient is moisture, usually pulled north out of the Gulf, feeding humid air into the lower atmosphere and giving storms the raw fuel they need to grow tall and violent rather than fizzling out as harmless showers. The second is instability, essentially a measure of how eager a parcel of warm air near the ground is to rise rapidly through the atmosphere once it gets a nudge, the same way a bubble races upward through water once it is released. The third is lift, some kind of trigger, whether a cold front, a dry line, or daytime heating strong enough on its own, that gives that unstable, moisture-laden air the initial push it needs to start rising. And the fourth, often the most important for determining whether a storm becomes a simple thunderstorm or a rotating supercell capable of producing a tornado, is wind shear, meaning winds that change speed and direction with height, winds that essentially take an ordinary vertical thunderstorm updraft and start tilting it, spinning it, giving it the rotation that can eventually tighten into a tornado. What forecasters are seeing build across the country this week is all 4 of these ingredients converging in the same general corridor at the same time across multiple consecutive days rather than a single isolated afternoon. Gulf moisture is being drawn northward ahead of the boundary separating the heat dome from the cooler air mass to the north. Instability is climbing as daytime heating intensifies across already baked, drought-stressed ground. Lift is present along the boundary itself, exactly where warm and cold air masses are colliding. And wind shear, driven by the strong contrast in temperature and pressure between the 2 air masses, is more than sufficient to organize storms into rotating supercells rather than ordinary disorganized thunderstorm clusters. When professional forecasters see all 4 boxes checked simultaneously across a multi-day outlook, that is precisely the moment language shifts from routine to urgent. It is worth pausing here to talk about scale, because it is easy to hear phrases like severe thunderstorm outbreak and picture something contained, something local. The reality is almost the opposite. A single supercell thunderstorm can be 20, 30, even 40 miles wide, towering 50,000 feet or more into the atmosphere, visible from space as a distinct, rotating structure. A squall line evolving into a derecho can stretch for hundreds of miles from end to end, moving at forward speeds exceeding 50 or 60 miles per hour, meaning a corridor of destructive wind can sweep across 3 or 4 states in a single evening, arriving in one community almost without warning simply because the system is moving faster than word can travel. This is part of why meteorologists stress lid time so heavily. A forecast issued days in advance, warning that ingredients are aligning across a broad region, gives emergency managers, school districts, hospitals, and ordinary families the chance to prepare before the specific hour and specific town affected becomes clear. Because by the time a storm is close enough for its exact path to be certain, there's often very little time left to react. There's also a quieter, less discussed danger buried inside a setup like this, and that is the compounding effect of consecutive days of severe risk rather than a single afternoon. When an outbreak strikes once and then clears, communities can begin recovery immediately. Crews can start restoring power, residents can start assessing damage in daylight and relative calm. But when the atmospheric pattern remains locked in place for 3, 4, even 5 consecutive days, as forecasters are currently suggesting is possible. Recovery efforts from one day's storms can be interrupted or reversed by the next day's storms before they are even complete. Downed trees only partially cleared from a Tuesday derecho become new hazards during Wednesday's flash flooding. Temporary power restored to a hospital on one night can be knocked out again less than 24 hours later. Emergency shelters that opened for one hazard suddenly need to accommodate an entirely different one. This is the exhausting, grinding reality of a multi-day, severe weather pattern, and it is precisely why forecasters keep repeating, almost like a mantra, that this is not the week to let your guard down. Consider, too, what this looks like for the people whose job it is to actually respond when these warnings turn real. Storm spotters, many of them volunteers trained by the National Weather Service, position themselves at safe vantage points during active outbreaks, specifically to provide ground truth confirmation of what radar is only inferring from a distance, information that can mean the difference between a warning issued on suspicion and a warning issued with certainty. Utility crews stage trucks and equipment in forward positions before storms even arrive, knowing that outages are all but guaranteed, and that speed of restoration will depend entirely on how close their equipment already is when the lines start coming down. Emergency room staff and hospitals across the risk corridor brace for a familiar surge, heat exhaustion cases in the hours before storms arrive, trauma cases in the hours immediately after. None of this infrastructure appears by accident. It exists because the country has learned, outbreak after outbreak, decade after decade, exactly how dangerous these setups can become when they are underestimated. It is also worth remembering that the human cost of these events rarely announces itself as dramatically as the storm footage suggests. Yes, there are the videos that circulate afterward, funnel clouds silhouetted against a green-black sky, debris balls glowing on radar screens, walls of dust racing ahead of a derecho's leading edge. But statistically, a significant share of the deaths connected to events like this one do not come from the tornado touching down in front of a camera. They come from a driver misjudging a flooded intersection in the dark. They come from a homeowner staying outside too long trying to save a shed instead of taking shelter. They come from carbon monoxide poisoning days later when generators are run indoors or too close to a window during an extended power outage. The dramatic moment gets the headline, but the quiet, preventable moment is very often what actually costs a life, and it is exactly the kind of danger that calm, early preparation is built to prevent. Zoom out far enough, and this entire pattern fits inside a larger story. Meteorologists have been tracking for years a story about an atmosphere that is, on average, warmer and holding more moisture than it did a generation ago, which means the raw fuel available for extreme weather events, heat domes, flash floods, and severe thunderstorm outbreaks alike has measurably increased. This does not mean every single storm is directly attributable to any one broader trend. Weather is far too chaotic and locally driven for such simple claims. But it does mean that when a setup like this one assembles, heat dome, drought risk, active monsoon, elevated fire potential, and a volatile severe weather corridor all converging within the same handful of days, the baseline energy available to make that pattern more extreme rather than less has shifted. Forecasters are not simply reading an unusually active week. Many are watching what a growing number of unusually active weeks stacked across recent years are starting to suggest about the seasons still ahead. None of that changes what matters most right now, in these next several days, for anyone standing beneath this developing pattern. The forecast has done its job, the ingredients have been identified, the timeline has been laid out. The warnings have been issued days in advance rather than hours, which is exactly the kind of lead time meteorologists spend entire careers trying to buy for the public. What happens next depends on decisions being made in kitchens and cars and classrooms across a dozen states, decisions about whether that emergency alert gets silenced or heeded, whether that flooded road gets driven through or avoided, whether that basement gets identified as a shelter tonight or only remembered as one after the sirens are already sounding. And that, in the end, is the part of this story that no forecast model can finish for us. The atmosphere has assembled its ingredients. The boundary is in place, the heat is building, the moisture is arriving, the shear is strengthening, and somewhere across the interior of this country, in the coming days, that energy is going to be released. The only real uncertainty left is exactly where, exactly how intensely, and exactly who will be standing beneath it when it finally breaks.